Welcome to session 4 or lab 4. This is going to be where you're going to now start working with the propane torch. Remember, I told you at the beginning of the semester or at the course that normally your propane bottles come blue and your MAP gas comes in the yellow can. Well, here's where it's not always the same throughout the industry. This is a white can, but be sure you read the labels. All right, this is propane. Checked it out, so we're ready to go. Now, from the last session, we cut our pieces of copper tubing. Now, the exact length, 3-4 inches. 4 inches, it's a little easier to work with for yourself. And the last exercise, you swedge the one side of the piece of copper tubing. Now, with the other scrap piece, which can be anywhere from 3 to 4 inches also, we're going to join these two together and solder them. Not only are you going to solder it, but you're also going to peel it open to check your solder joint. Now, the whole process is pretty simple, but you have to pay attention to what you're doing. If you use too much heat or not enough heat, the capillary action for the solder will not take place. You also want to build a nice little crown around the top edge where the two pieces join. Now, the objective when you're done is this piece where you swedged is all going to be filled with solder, and there's going to be a little crown on the solder joint. And you'll see that when you read your homework, it shows pictures of that, and that's exactly what you're going to try to achieve. All right, so let's start. Get the glasses on, your gloves. Be sure you got your long sleeve shirt. Again, the reason being is there's going to be more than just yourself working at this table. There may be up to 4 people working here. And you'll always constantly have to pay attention to what's going on. Now again, clear glasses only, solid gloves. You got your 2 pieces of copper tubing. Now again, remember, wherever you did the swedging, you're not going to have to ream it. It's already been reamed prior to making that swedge. So now all you have to do is take your 1/2-inch pipe wire brush, go around a couple times. Now, of course, they make different versions of this wire brush. Whatever makes you comfortable, use it. All right. Now, again, be sure that it's very clean, because if it isn't clean, that solder, no matter how much flux you put in there, will not stick. All right, that portion is cleaned. Now, I take my sandpaper, cut off a little piece. I take the extra 3-inch or 4-inch piece that's going to fit inside my swedge, and I start to clean that corner or that edge, the one end of it there. Now, to do this, just rotate it and put a little pressure on the sandpaper. You want it nice and clean again, because any oxidation will not allow that flux to stick, or the solder to stick with the flux. All right. Ensure that all the crevices, it's clean copper. I can't stress that enough, especially when you're on the job site. If it isn't clean and you put it in there and there's a little gap, it will hinder you. So now we have the swedged end cleaned and the male end that's going to stick into the female end cleaned. So therefore, this is what we have ready to go. Now, back to our bottle. Our propane bottle, again, should be blue, but could be different colors, possibly white. I don't think I've seen any other colors out there, but the industry always keeps changing their mind. Also, be sure that you put it in your stand for safety reasons. All right, you should also have a roll of solder in your toolbox. All right, this is located wherever the torches are. Now, if for some reason during the time that you're doing your exercise you run out of gas or run out of solder, or the flux is bad, or whatever the situation is, you need to let us know. Now what we're going to do here is we're going to do it in simple stages. We've set up our equipment and it's ready to be soldered. Now we're going to move over to our table. When we move over to the table, understand that you should have the water can full of water. All right. Your vise should be tight and in firm place. And you will always need to have the exhaust fan on. The exhaust fan is located against the back wall by the back door, and it has the word exhaust fan on it. And just hit the switch and it will operate the exhaust fan. Now, before we move over there, let me show you your flux, and it should be a flux brush inside the bottle. Now, be sure that the flux brush is in good shape. The flux, remember what they always tell you to do is stir it up and mix it up well so that you have a clean flux on there. Again, if the flux is dirty, it's going to hinder your soldering techniques. All right, so we want to have that nice and mixed up. All right. Spend the extra few seconds that it's going to take you to do it right. Guarantee you, I've been there, done it. If you don't and you're in a rush, it's going to come back and bite you. You're going to be soldering, you're going to get it all done, you're going to turn the water on or the air, and it's going to start leaking. Now you got a major problem. Hopefully you can solder it right back and seal it up. But if that's dirty or wasn't cleaned correctly or the flux was bad, you got a major problem on your hands. All right, so we know we got all this prepared. Let's go turn on our vent and start the exercise. Now, for simplicity in the classroom, in this exercise, we're not going to use the exhaust fan because of the sound. When you come out here, be sure that you have the exhaust fan on. Now, since our system is set up and we're ready to go, we have all the equipment that we need. Now we're going to go over to the back wall by the back door, turn on the air so that the vent works properly. Now the soldering fan is located on the back wall by the back door. It's unit 3, it says soldering fan, just turn it on. Okay, now the first thing you should do is when you get to the site, be sure that it's clean. If it isn't, let me know and I'll get somebody on it. The other thing is always place your rag up there so it can dry out from when you're done with the operation for the day. These are pipe wrenches or pipe vices. We're not using them for heavy duty strength, so just take it easy with your copper tubing because copper tubing bends very easy in here. All right, we pick up our copper tubing, we take our female end, which has a swedge on it, and we just lightly place it into the vise and tighten down on the handle. The next thing that we want to do is we're going to dip into our flux. Now, when you flux, you want to put a very light coat on there. And you want to go up about 3/4 of an inch and be sure that it's a light coat because most of this you're going to remove. So, and you only put it on the male end. Do not put anything on the female end. The reason being is, as this heats up, remember the flux is going to flow, and as it heats up, it's going to run. And wherever it runs, so will the solder. So, what we want to do is insert it into our female end, rotate it 90 degrees, take our rag, and wipe off any excess solder, or flux, excuse me. Okay, any excess flux that we have. Now, you may be able to move that tubing a little bit, but don't worry about that because you want it just firmed up. All right, we're not worried about squishing the copper tubing at this moment. Now, from now on, you got to concentrate for safety reasons who and what is around you. We are going to use our propane and our solder. at this point. Now, here's a couple key factors that you need to pay attention to. Whatever the width of your solder is, or the diameter in this case, whatever the diameter is of your solder, you want to use that much solder, i.e., in this case, it's 1/2 inch. Therefore, we'll use about a 1/2 inch of solder. Now, the reason that it's a guide, it isn't the Bible, it's just a guide. Because if I keep letting this suck into the copper tubing and it starts falling through, that's a no-go. You're not going to get credit for that. All right? You don't want restrictions inside your tubing. And as long as that copper tubing is hot, at that temperature that the solder melts, it will keep sucking that all in. So you have to be paying attention to what you're doing at all times. All right. Now, ensure that all your equipment's set up. Your turbo torch, turn it on by opening up the back valve. While you're in the classroom, do not use the locking device. All right, just leave that alone, just because of safety reasons, until you get used to using the tool. You don't need to use that in here because of the speed that we do things at this level of the lab. It is a trigger finger, so all you have to do is push down on it and it'll light. Do not try to adjust the flame. All right, we want this type of flame. Do not be playing with this and trying to turn it down real low. What you're going to end up doing is ruining the inside of this. Let it blow out at full speed. What you're going to do as an artist, basically, is adjust your flame distance, and that will adjust your heat content. Now, we do not want this cherry red. Solder melts at somewhere around 250, 400 degrees, depending on the type of solder. What you want to do is you want to enter from the back, because at that moment when that solder melts, the whole copper tubing is at high enough content that it will take in all that solder and do the capillary action that you want. You don't want to put so much heat on there that it should turn this a bright orange or get it real dark, because then you're putting too much heat on that, and what it's going to do is burn up your flux. After flux reaches about 250, 300 degrees, it starts to burn off. And once it burns off, you're not going to get that solder to stick, no matter how hard you try. So what you want to do is you want to make a happy medium. And the key to soldering is not to be in a rush. Now, what I'm going to show you is what not to do immediately. You turn your torch on, you hold the trigger in. Do not go right up on top of it, all right? Do not do that, because that's so hot that it's going to burn off all your flux. Again, patience. What we want to do is we're going to light it and bring it out a distance so that it just starts to warm the copper up. Now remember, you want to do the male end first, bring down your heat content to about the middle lower bottom half of your swedge down here. This is where your flame is going to be at, because you want to draw it down and you want to draw the copper or the flux in the solder around for that capillary action. So my solder is out of my way because the copper tubing is not at the temperature I want it. Light my torch. You see where my flame is at. I'm about 3 inches away, and I'm just kind of warming it up, but I'm still back a distance. Now, once I have that, I focus my heat on bottom, and you see how it rotates right around. I want to pull back, and it's sucking it right in. Now, as that cools, what you want to do is, again, bring that heat back, but be off a distance. You just want the solder just to barely melt now. We're trying to put that cap on this thing, and you don't want to put a lot of heat onto it. Now, let it turn kind of a dull silver, and then you know it's time to wipe your solder off. Now, you notice that my copper tubing is not all burnt. It's not scorched. It's nice and clean. It's professionally done. It's got a nice low cap on it. That's what is going to be expected of you. Nothing less, nothing more. You're going to do this as many times as it takes to get the technique down. This is only half of the operation though. So once you're done and you cool this off, and there's several ways of doing it. Once this is cool to a touch, pick it up, just drop it in the water, pick it back up and wipe it off. Now, when you're done, you should have a piece of copper tubing that is not all blackened, there's not runs all over the area, and that there's a nice little seam all the way around this. That's part one of the exercise. Part two follows. You're going to put your copper tubing inside the vise. Raise it up just a little bit above the head of the vise. Put some pressure on it so it doesn't move. Now, what you're going to do is you're going to cut this at a 45-degree angle. You're going to come across here at a 45-degree angle with the hacksaw. Now the hacksaws are located right above the work area. You're going to draw it in slowly. You're going to just cut through the top portion of the first piece of copper tubing. You don't want to cut all the way through. The reason being is you're going to peel this back. And this is the only true way of finding out if it's been soldered correctly. So, once you have it soldered, and it doesn't matter at this point in the course that, let's say you do have runs or drips, it's burnt, whatever. You're still going to do this portion of it because you need to find out if your technique is correct. You can always adjust by pulling back on that flame later on as you learn to redo the exercise again. Now, what you're going to do is you're going to come back at about a 45-degree angle and lightly take the hacksaw, draw back on it, get a saw kerf in there. A saw kerf is nothing more than a little guide for the saw to run in. You want to do a light drag across it and just barely get to a point where you're in the copper tubing to the other side. Put your tool back. Now, at this point, you're ready to peel it back. Now, to do that, you'll need the cold chisel and your hammer. Go to your toolbox, pick up your cold chisel. Now, your cold chisel, be sure that it's nice and sharp. It doesn't have to be razor sharp, but it has to have no nicks and dings in it. If it does, let us know. We'll get it fixed for you. Your steel hammer, bring it over here. The other thing that I want to mention that isn't necessarily important in this course, but for tool safety, the top of your chisel needs not to be mushroomed. If it's badly mushroomed, let us know. We have to grind that down for safety reasons. Now, what you're going to do is you're going to hold the chisel in one hand right at the edge of where you made that cut. You're going to gently tap onto your metal. Now, what may happen is, what's happening here is the copper tubing slipping. All you have to do is loosen up your vise, bring it down a little bit, and reset it. Now, you can squeeze this copper tubing at this point because as far as being conforming to a round tube, it's not necessary at this time. Again, put your chisel back underneath, and you want to peel it back. Now, you see how I just popped that off? there may be times that you're going to have to adjust this, adjust this several times. All right. Now, what you're going to do is, again, tighten it back into the vise. You are going to now use the vise grips. Get them out of your toolbox. Open them up. Now, these are locking pliers, all right, or better known as vise grips. You're going to put that onto whatever metal you peeled up. Be sure you got a nice tight grip on that. And peel it back. Now, that's only partial. What we want is you're going to keep gripping it until you either pull it totally apart, all right, or it all comes off nice and neat. Now, this is what you're looking for. Nice solid joint all the way across. If you don't have that, it's not acceptable. All right, and what you may have done is if you have voids in it, all right, it will leak eventually, vibrate loose, break away. This is the only acceptable means of moving on in the course. It's got to be this way. And what may be is as you get larger copper, you have to circulate that heat around it. All right, do the 180 on both sides so that you know you got good heat exposure on both pieces. Be sure that you got enough solder in there. Now, what we're going to do is we're going to show you what you're going to see if you make a mistake. All right, now what we're going to do is I did an exercise, another one, where I'm pulling it apart again to hopefully show you what a bad solder joint is and what will not be acceptable. Yep, I was successful. Now, what we're talking about is right there. What that means is when it is not burnt, what happens is the heat content did not flow around it 100%. That means when it's clear that you didn't get enough heat on it. If it's black or dark color or stained, it means that you burnt the flux away and there was no place for the solder to flow. So one of those two options are going to happen. And don't be upset, it's going to happen initially until you get a feel for the torch. Again, you see how everything was nice and soldered after that, but because this was in the back and I did not move my torch all the way around at 180 degrees on both ends, the metal didn't get hot enough. It got hot enough above it and a little bit below it, but then it hit that void where there wasn't enough heat on it, and it just circulates right around. Remember, the solder will only go where the flux is hot enough to contact the metal. Therefore, this is what we want. This is not what we want. All right, if you have a void, it doesn't count. You just redo it until 100% of your solder joint is like this. This is the only acceptable means. Once you've met that, then you can move on to the next project. Now remember, every one that you do, you got to show to the instructor or myself. This is the only way we can help you. Don't go do 4 or 5 of them and then realize that they're all bad. You're just going to irritate yourself, waste a lot of energy and time and money on equipment that you didn't need to do. Normally something like this can be fixed very easy. We just watch exactly what you're doing and give you a little bit of tips on how to fix that. It's very simple. It just takes practice. This is a hands-on class. This whole course, you're going to do nothing but hands-on because this is the only way that you can learn. You can watch the video that I'm showing you, but until you get your hands dirty, it isn't going to help you out. So don't get discouraged when you find stuff like this. Just remember, show us so we can give you a few tips, and then we'll watch you do it again and see what happens. All right? Now, also, just if you have 3 or 4 of these and the instructor or myself misses it, remember that this also could be a sign that the flux is bad, all right? It's dirty and it isn't sticking, but because all of it was nice and clean and stuck very well, that tells me it isn't the flux, it's the operator, all right? So pay attention, just take your time, but don't spend way too much time on it because again, you're gonna burn that flux off. I hope that you understand what we're trying to get across to you, and hopefully you'll have a good, enjoyable time doing it. Again, safety is the utmost importance here. You have to pay attention to what's going on around you because the other students may not be. Always think safety before you do anything. I hope that you have a good time doing it. You're going to do it until you do it right, and then you're going to move on to the next project. Remember, propane is the lesser of the two evils here because MAP gas gets much hotter. Propane, 250 to 400 degrees. MAP gas up to 800 to 1,000 depending on the torch. So therefore, once you get this technique down, I guarantee you, when you got joints like that, they'll never leak on you. Never in 100 years, all right?